have multiple foci. They're on interactions between land management and water and soil resources. Stephen has more than 100 papers and book chapters. His current research has a strong interdisciplinary approach. He emphasizes development of water quality standards for headwater streams that are impacted by surface mining in the Central Appalachians with a significant policy component. I tried to suggest to Dr. Schoenholtz that it was cold here right now. He looked at me in disbelief. He couldn't understand what I was talking about, but I tried to explain that when we get down into the 60s, we all walk around in puffy jackets. Dr. Schoenholtz has mentored 41 graduate students thus far over his career, 3 postdoctoral research associates, 5 research assistants, more than 30 undergraduate students, all from a diverse range of academic departments, and I believe distributed among 3 different universities is where they're coming from to be part of his research program. His teaching experience includes 16 different undergraduate and graduate courses. He's developed and coordinates a new interdisciplinary undergraduate program, degree program in water, resources, policy, and management at Virginia Tech. And as I understand, it's the first of its kind in the United States. Dr. Schoenholtz earned his BS in biology and forest science from Penn State, an MS and PhD from Virginia Tech. And he's traveled pretty much all of yesterday to get here and entertain us with his seminar. Thanks, Steve.
Thank you, Garen. And thank everyone for coming out for a free lunch and hopefully enjoyable lunch break. So I'm going to talk about the title here, Rising Tide, give you some information on some of the water challenges we face in the mid-Atlantic region and specifically in Virginia, but much of what I'll talk about is relevant to the mid-Atlantic East Coast, and look at how Virginia Tech has responded to some of the challenges which propel us towards innovative scholarship, research, and engagement. So what I'll do today, as you enjoy your quickly cooling off pizza in this freezing cold weather we have, is talk about some of the regional challenges, give you an overview of how we do things at our water center at Virginia Tech, and also give you some overview of the campus in general, what Virginia Tech has done in response to some of the challenges. So, water, as everyone I assume in the room knows if you're here, there's a lot of complex challenges involved with any water resources issue. What we look at in the mid-Atlantic, particularly again focused in Virginia, is one of the challenges is coal mining, which is still quite prevalent in the Central Appalachians and has major impacts on water quality and aquatic biodiversity. We have lots of fracking occurring, which has ramifications for water quality, water use, and also disturbance of ecosystems by building some pipelines. I'll touch on that quickly. Coastal zone inundation, climate change. I'm here partly because I'm reviewing the pre-proposals. There's a lot of discussion of that here in Hawaii for sure. Groundwater availability and saltwater intrusion, a major issue in Eastern Virginia where there's tremendous population pressure through rapid urbanization. Also aging infrastructure, again, many of these are the similar issues you face here. Stormwater management is a major issue that we work on. And then we have the Chesapeake Bay, which is pictured here, which for the most part is not meeting its pollution diet, its total maximum daily load issues that are supposed to be met by 2025. I'll talk about that again briefly as I go through. And then trying to work through this water policy planning and management, and overlying the whole thing is this whole idea of uncertainty. And that uncertainty comes from ecological, hydrological uncertainty. Our models are based on uncertainty, climate change uncertainty, economic uncertainty. I can go on and on. Political uncertainty, there's a lot of uncertainty as we try to grapple with these complex problems. So the problems are complex enough, and then there's this blanket of uncertainty from a social, human dimension side, as well as our biophysical understanding of the issues. So in terms of coal mining and fracking, and I'll show this map several times, these are some of the major geologic divisions in the state. It's very diverse, from the coastal plain on the east coast. This is the Chesapeake Bay here, right in here, and that's what's called the Eastern Shore. That's the Virginia part, and then up above here would be the Maryland, and it's called the Delmarva Peninsula. And of course, right here is Washington, D.C. And Maryland, and that boundary is the Potomac River. So those are the major geologic formations. And in the coal mining and fracking, it's mainly in the Cumberland Mountains in southwestern Virginia, and much of the dominant work has been done in West Virginia. And one of the issues is mountaintop removal, which is not a subtle impact on the landscape. There's hundreds of thousands of acres that have had mountaintops removed, and when they remove the mountaintop, they put the exposed materials into the valleys. It's called valley fill, and bury streams, literally bury streams, headwater streams. And so this creates plenty of water challenges amongst other ecological issues. So this is a scene from southwestern Virginia where mountaintop removal is actively being conducted here. And then one of the other issues we face is natural gas pipelines. Much of the fracking and natural gas out of the Marcellus Shale is coming out of West Virginia, and these two proposed pipelines they're halfway done. The lawsuits involved here, the citizen involvement, the stakeholder issues are very complex. And again, the economic uncertainty, the ecological uncertainty, and these pipelines cross several of these geologic formations. Many thousands of stream crossings through wilderness areas, etc. And I'll talk very briefly about that as well. This is one that goes right near Blacksburg, which is right here. And there's been a lot of controversy about this pipeline that's currently being built, but is now stopped because of lawsuits. This is basically just what it's looking like as it goes through the landscape. On top of that, our biodiversity hotspots, and of course highlighted right here is Nature Conservancy hotspots, certainly the Hawaiian Islands, but also the central and southern Appalachians have some of the highest species diversity in the world. And in the case of the central Appalachians, it's aquatic biodiversity. In the streams, rivers of the central Appalachians, there are 41 species of freshwater mussels, many of which are threatened and endangered. So we've got coal mining, fracking, pipeline building in this part of the state, in some of the areas that have some of the highest aquatic biodiversity in the world. Now we get into the coastal zone, resilience and climate change, inundation, and that's basically along the coast with many of the similar issues we have here, or you have here in Hawaii that I've read about in reading all the pre-proposals. Major issue in Norfolk, Virginia, the largest federal base, Navy base in the country is there, and major threats from flooding and coastal inundation. This is a map of Norfolk. All the yellow here has high-risk flooding in the next, in the century, and scenes at the lower right are quite common, more frequently now than ever, as weather events are more extreme. Groundwater quantity is a major issue in eastern Virginia, where the high population growth is. They're pumping water and basically mining groundwater. The water tables are lowering at frightening rates, and lots of challenges in terms of how we're gonna have sustainable long-term groundwater supplies in the coastal plain of Eastern Virginia. And then, as I said, rapid urbanization is another issue along the Norfolk-Richmond corridor, which is in here. And in Northern Virginia, which is out in the suburbs of Washington, D.C., has had the highest population growth in the country, is Northern Virginia. The ex-urbanization, the development there is very rapid and creates lots of water challenges. So, urbanization's an issue, and these are a couple of photos I stole from Northern Virginia, the Potomac River up in the upper photo. And then the Chesapeake Bay creates many challenges because it involves not just a big watershed, but 7 different political jurisdictions, if you will, 6 states in the District of Columbia, all with their own politics, and major pollution in the bay, point source pollution from sewage treatment plants has by and large been successfully treated because that's point source and we have the technology to improve our sewage treatment plants. But the non-point sources from agriculture and stormwater creating problems in the bay have been a major challenge to meet expectations, which have not basically been met. One thing I like to think about when I'm talking to students in the class, if you think about this watershed and all the efforts to control water quality and improve the state of the bay, think about all the agriculture, all the farming to grow plants, and all the production of cows, chickens, pigs, and the amount of nitrogen that is brought into the watershed from outside. So we're not trying to fix a watershed that's broken with a set amount of nitrogen that we're working with to protect from getting into the water. There's literally millions of tons of nitrogen being imported into the watershed each year to feed the chickens and the pigs and the cows and to grow the corn and the crops that also feed the humans. So it's a great challenge because there's so much nitrogen coming in every year. Very challenging. The bay makes up part of, or the bay watershed is this part of Virginia. It's not the entire state, but those counties drain into the watershed of the bay, and so we're part of the solution to try to clean up the bay. Just in terms of the final part of where we stand for impairment listed by our Department of Environmental Quality in a report that just came out at the end of January, 15% of our rivers and streams, 81% of our lakes, and 75% of our estuaries are qualified as impaired, meaning they need total maximum daily load procedures on them, and that's from pollution. And the causes for impairment can range from low dissolved oxygen, high bacteria counts, degradation of benthic communities, and also PCB and mercury in fish tissue. So there are a myriad of problems or causes that impair these waters. And so there's a tremendous challenge ahead of us, or with us. And so that brings us to how the Water Center works in this complex climate of water challenges and how we address some of this at the Virginia Water Resources Research Center. As Darren mentioned, we're part of the Federal Water Resources Research Act, and I have a great time with this in classes. Most of the time, the students in the classes don't know who that's a picture of in 1964. Uh-oh. Ali, where are you? Time to retire when nobody has heard of the Beatles. In any case, 1964, the Water Resources Research Act created this water center and the other 53. Ours was established at Virginia Tech a year later. And in our case, the Virginia Assembly created created us as a state agency in 1982. So we're authorized by both the federal government and by the state of Virginia, or the Commonwealth of Virginia. And the Commonwealth created us for the purposes of developing, implementing, and coordinating water
and related land research programs, thank you, in the Commonwealth, and transferring the results of research and new technology to potential users. And so what we do with that mandate from both the federal government and the Water Resources Research Act and from the state is we provide research and educational opportunities to future water scientists. And that's through our competitive grant program. Again, a lot of this is probably parallel to what happens here, through internships and fellowships that we offer to students throughout the Commonwealth, not just at Virginia Tech. So we're giving opportunities to students and researchers throughout the Commonwealth. It could be at the University of Virginia or George Mason University or William & Mary. It's not just at Virginia Tech. And what we've really focused on with limited resources financially is really pushing the water resources curricula at Virginia Tech. We encourage studies of practical solutions to water resources problems through our competitive grants program, and we work on facilitating transfer to water information to water resources, transfer of water resources information to stakeholders and decision makers. Again, that's why I'm interested in communication and how we do it, and some of the ways we do it are current Twitters and Facebooks and podcasts and things. This is who we are. It sounds like we're quite a bit smaller than certainly the Sea Grant program here, but also the Water Center. I report as a director to the Dean of the College of Natural Resources and Environment. The Water Center used to report to the Vice President for Research at Virginia Tech, and in 2006, which is when I got there, it switched over to the College of Natural Resources. I also report to advisory board appointed by the governor of the state of Virginia, and then there's an associate editor, Kevin McGuire, and then some research assistants and faculty members. The only people who are funded with state money, with hard money, are myself, Kevin McGuire, and Inga Solberg, our business manager. The other folks there are on soft money, or in the case of the two professors, there are line items in another department, but they're affiliated with us on a small scale. Most of the funding comes from our USGS grant, just like we get the same amount as you do here, a whopping $92,000 a year to conduct our mission. It doesn't go very far, but it's fine. The Commonwealth of Virginia gives us some funding, and then most of what we do is through grants and contracts and proposals we submit. Our funding supports our salaries, generally 15 to 20 projects that are ongoing each year, our seed grant programs of grad students, undergrads, research associates, and student interns. So that's where the money goes that we are able to acquire. One of the things we really work hard on, since we don't have a lot of research money to distribute to all the capable faculty all over the Commonwealth, is we really put our effort into information transfer. Right now, for example, we keep track of all the water-related bills in the Virginia legislative session, which goes on each year from January through February. This year in Virginia, there are a lot of distractions, which I won't get into in terms of political discussion. Many challenges, but the General Assembly, we keep track of all the water-related bills. And some years there can be well over 100 bills that have something to do with water, and we're looked at as a go-to place. You want to know what's going on in the legislature in January and February each year, you can look at our website and see what's up. We have a water news grouper that keeps track of all kinds of water news, events and resources, and then we do a weekly listing of water announcements, jobs, conferences, news things that each week the website gets updated on the front page with water announcements. So we try to keep it current and updated and moving almost on a daily basis. Other information transfer we work on, we've got a stormwater best management practice clearinghouse that's been funded by the state for the last 15 years or so, and this is the go-to place for any developers who want to look at stormwater best management practices. They go to our website. We have an academic advisory committee. We work with DEQ and get funding from them. That's the Department of Environmental Quality, looking at nutrient criteria for freshwater streams and rivers, which in a diverse state geologically is extremely challenging to come up with water quality criteria in the mountains of the western part of the state, headwater streams cascading down over beautiful waterfalls, versus the eastern part of the state where you have blackwater swamps. And if you try to come up with water quality standards that fit the whole state, it really doesn't work. So it gets complex and complicated quickly. And we work with trying to help DEQ to work under the auspices, of course, of EPA, overseeing it all. We have a water educators directory. We keep all of the environmental ed water educators at K through 12 in the state updated pretty much on a weekly basis of new information, new resources available for environmental ed. We run water conferences, and over the last 7 or 8 years, the Virginia Water Center's taken the lead with West Virginia in developing mid-Atlantic water conferences involving 6 or 7 of the water centers in the mid-Atlantic region. And then one of the things that we don't have a television show every Sunday night at 6, but we do have a radio show that's broadcast on a couple of radio stations across the state, and we have podcasts that are available every Monday morning, and we have standards of learning for the K through 12 teachers based on that the topic of that water show each Monday, and that goes out to 600 or 700 teachers across the state, with the hope that they can download the podcasts on the radio, water radio, and use it in their teaching. So that's part of our information transfer. These are things that we can do that don't cost lots of research money, and that we can partly meet our mission. At Virginia Tech, we're looked at as a clearinghouse for water activities and coordination. We oversee a watershed management minor and a graduate certificate. And then what I'll talk about in the next few minutes is we coordinate interdisciplinary water curricula. We have an undergraduate water degree, which I'll explain to you momentarily. And then we're also developing what's called a Blue Planet interdisciplinary minor and graduate water degrees at master's and PhD levels. So our response to all these complex water challenges is to develop new curricula. We have research centers supporting water resources research. There are centers and institutes at the campus who do that, who have a lot more funding and money than we do. We also have a new focal area in global systems science that has a major water emphasis that's gotten considerable funding from the provost's office. We have the Blue Planet minor. We're looking at a new interdisciplinary grad water program. And then I just learned of this about a month ago. Has anyone heard of Future Earth Coasts? This is an international group that is a nonprofit that has 5 global centers, one of which is now at Virginia Tech as of this right around Christmas, before the holidays. And their major effort is to look at coastal inundation and coastal issues. So check that out. I don't know much about it. I do know that we have a coastal resilience group in our university, and they acquired one of these global centers. The only other one in the US is at the University of Maryland. There's one in Germany. I think there's one in Australia, and I don't remember where the last one is. But that's a new initiative that just started. Okay, in terms of the water degree, this is the only interdisciplinary undergraduate water degree in the US. And it's gotten a lot of publicity, a lot of support, and it's been an interesting, challenging experience in developing it. One of the reasons we looked at it was water looked like a very rapid emerging area where we could train students in terms of connecting the society, the human side, the social side with the environmental side to all kinds of systems. It's not just hydrology, it's energy and food. It's impossible to separate energy, food, and water. We're talking about climate systems, ecological health, human health, as everyone knows, is intimately tied to water. And economic, social, political, cultural systems. You can go on and on. There's all kinds of systems, all interacting all around this resource of water. And so we looked at it and said it would be amazing to be able to train students in an interdisciplinary way to look at some of these complex problems. And so we looked at increasing demands for water, complex challenges and solutions. And in developing the degree, I went around to many federal agencies, to private industry, to NGOs, and there are amazing job opportunities now and in the future. Water as a job opportunity and career opportunity for grad students or any undergrads isn't going away. This is not a flash in the pan current event that's going to disappear in a few years. It's obviously going to become more and more and more of an issue, which creates more and more opportunities for training and students and jobs. One of the things I like to say is I interviewed Earl Green, who comes here often, I guess, from USGS, people from EPA, the USDA, the Forest Service, federal agencies. They said invariably most of the white men who are in those agencies are about to retire. They look a lot like me. They're going to retire in the next 5 years, and the opportunity for a diverse, inclusive, new force in the federal agencies is phenomenal. Everybody said, you should do this, you should do this. I have letters of support from agencies, state, federal, NGOs, private industry, on and on. So lots of opportunities. And then Vice Associate Dean, who I just met, I'm terrible with names. Chip?
Yeah.
Chip, we involved 5 colleges and 10 departments. This was an enormous political challenge at a university because everybody wants to protect their own resources. But we were able to do it. We have 5 colleges, and I put all the departments here because it took 4 years to do this, of politicking and making sure everybody was okay, with nobody was losing, and everybody was winning in the process. And so we have everything from ag and applied economics, biological systems engineering, crop and soil environmental sciences, urban affairs and planning, civil, fish and wildlife, forest resources, geography, biology, and geology. And they were all part of the committee that we worked on for 4 years to develop the degree. In the process, the provost gave us 7 new faculty positions. It was amazing. Before the degree was approved, we did a cluster hire at Virginia Tech in 2013 and added these 7 positions to 4 departments across that list of departments. Everything from water policy and economics and the human ecology of water to the biophysical and modeling type stuff. So 7 new faculty. In fact,
I was one of them.
did you apply?
Yeah.
Okay, so these guys are all up for tenure right now,
Yeah.
just like you. I'm on my college P&T committee, and we submitted the packets at the end of January, and everybody here is up for P&T.
Yeah.
Did you interview?
Yeah, I was
How do
there.
you know?
And yeah, you
For which
interviewed
one?
me, you gave me a tour of the campus.
We're informal. For which one?
It was hydroinformatics.
The hydroinformatics.
Yeah, maybe it was
Oh,
number 6.
that,
You're
okay.
not in music right
That,
now.
that
But
became, hydroinformatics was this one.
Yeah.
We ended up hiring an
You closed that
eco-hydrologist.
position.
We
I know.
hired Daniel McLaughlin from the University of Florida,
Uh-huh.
who's not a hydroinformatics person. He's a techno-eco-hydrologist who knows a lot about new designs of fancy monitoring equipment. So your search, we redid it.
Close that,
Yes. Okay.
To our great fortune.
There you go. And this time of year, you're probably in a better place at least. But seriously, those 7 faculty are all up for P&T now, and they've expanded our program. And so the students all have to take a core set of courses: water, environment, society, physics, hydrology, environmental science, water quality, and watershed assessment, management, and policy. They have to take those courses. And then they have to pick one of these specializations: aquatic ecosystems, hydrology, or water quality. All right, now listen to me as we go through this. Interdisciplinary degrees traditionally, most of the time, run into all kinds of issues. The first thing everybody will say is they teach us a little bit about a lot, okay? And in terms of expertise and going into the job market, who are these interdisciplinary people if they don't have some level of discipline? We call it T-based learning. Has anyone heard that term? T-based learning. And the focus here is the top of the T is there's not a whiteboard. The top of the T is the broadening interdisciplinary expertise that you learn about in terms of, let me get to T learning. The students also have to take a policy specialization, either water policy, planning economics, or water, climate, energy, and global issues. So when we do T learning, and this is what their curriculum looks like, they have to have the top part of the T is where they get broadening. So if a student comes in who is thinking about civil engineering or very math oriented, they're going to definitely want to go water sciences into hydrology and water quality. That's where they're going to really want to specialize. But we force the civil engineer, they have to go over here, and they have to take at least 4 courses in water policy specializations. So that engineer, and trust me, I'm not taking over civil engineering. If I'm going over the bridge on the way home, I want it done by a civil engineer who's got expertise and disciplinary training. But if I want somebody who's working with complex water issues, trying to solve policy, science, interface stuff, maybe an interdisciplinary person who's learned something about the policy economics, the social issues, might not be a bad person to hire. They're not going to build the bridge, but they've also had training on both sides. The beauty of this T is the bottom of the T is where students can take up to 12 courses in an area that they want to study and become experts on. So the T learning, if somebody wants to be very civil engineering and go into hydrology, they're going to take a whole bunch of hydrology classes and have pretty good expertise. Again, they're not professional engineers and they're not ABET accredited for you engineers. On the other side, a student who wants to go to law school will spend a whole bunch of courses here in the social side and a whole lot over here, but they still have to get a little exposure. So that's what the T learning is. You get exposure at the top of the T, but you have enough focus to get some disciplinary expertise where you can actually apply for a job. Okay, so that's how it works, and that's the overall structure. It's been very successful. The first students came in the fall of 15. We had 13 students then. Our first graduates happened in the spring of 17, and right now we're graduating. We've graduated about 20 students, so our graduation and influx looks like we're leveling out at about 60. The students who have graduated, every one of them except for one who I can't keep track of. He never responds. Everybody else has a job or they're in grad school. They're in law school, they're getting PhDs at the University of Arizona, at UC Davis, they're getting master's degrees, they're working for Big Four, it's not Doolittle, it's one of the Big Four accounting firms. Somebody's working for EPA. They all have jobs. Peace Corps, AmeriCorps,
and private corporations. So we've been very, very lucky and fortunate that this seems to be a degree that's attractive to lots of students. The other thing it's been attractive to, Associate Dean, is philanthropy. I have actually gotten calls and emails, random emails from people who see the website who have offered scholarship funding. I am not an endowment development person. I'm not going out looking for funding. We have over $500,000 in scholarships and fellowships that have come in. I actually, great story, had a random email from somebody I never heard of. I was about to hit the delete button saying, I see you have a new water program. Do you want money? Spam. I mean, come on, are you kidding? Somebody I never heard of, some Gmail account or something. And I go to my development officer and I say, yeah. Well, we've met with the guy 2 times. He's a millionaire, lives near Myrtle Beach, South Carolina, who made a fortune in the pharmaceutical business looking at water quality issues with pharmaceutical emerging contaminants. And he's talking about giving us money. I didn't even ask him for any. In any case, $500,000 in water scholarships and fellowships for research projects. One of the students who worked with us, who graduated and is now doing a PhD, worked on the Flint water crisis. Got funding to go up there for 2 semesters. She got $10,000 that went into Mark Edwards, the civil engineering guy who did Flint, worked with him. So it's been very encouraging in terms of the support we have, and we can offer lots of scholarships. We got invited to the White House Summit in 2016. We've been featured on the website for UCower, and I've been invited to give presentations at national meetings. UCower, the University's Council on Water Resources, this past year at the American Water Resources Association annual meeting. And several universities who are interested in this type of program. And then I was in New Zealand on sabbatical 2 years ago, and I gave some talks there looking for student exchange and study abroad opportunities in New Zealand. So we've had good recognition, and it's been a very positive experience, and students are very pleased with how it's worked out, and we're very encouraged. So just to finish up, some of the Virginia Tech initiatives to meet these global complex water challenges. There's a Global Change Center at Virginia Tech that was established in 2014, looks at interdisciplinary research and training for global environmental challenges, and they look at habitat loss, invasive species pollution, disease, and climate change. That program has an interdisciplinary PhD program. I've had one of my students finished in that. It currently has 54 PhD students in it as of this semester. Now, the credit goes back to their home departments. So my home department is Forest Resources and Environmental Conservation. That's where I have my tenure. So my student, the credit goes back to my department, but my student was in this interdisciplinary global change program. Tremendous program, very attractive to students from all over the world. And there are 54 PhD students in it right now from across the campus. Must be a dozen different departments. The university put in major money into destination areas, one of which is global system science, and there's freshwater and coastal water systems, rural environments, food production and safety, and infectious disease thrusts. And there's money being produced from the President and Provost's office to fund initiatives in those areas, all related obviously to water. And then, as I said, this Global Center for International Future Earth Coast Program just got started. I don't really know much about it, but that's supposed to be very relevant to coastal resilience. Okay, as I mentioned, we are, as of the fall of 19, we're going to have what's called a blue planted interdisciplinary minor. Be a lot like the
the major that I just discussed, but again, will force STEM students who want to get a little exposure, somebody in physics or engineering or math, get some exposure to water, they will go to a social policy side of the water equation. And those who are artists or musicians or English majors or history majors will actually have to take a couple of science classes and force them into learning a little bit about the biophysical science side of water. And that's about to come online in the fall semester. As I mentioned, I'm working on an interdisciplinary grad water degree program. The hope is that'll be ready in 2020. That involves 15 departments and 7 colleges, and I could discuss that later if anybody's interested. The challenges there are amazing because that one is not affiliated with a college. It's truly affiliated with just the grad school, and there are a lot of challenges, but there are 7 colleges. Every dean I've met with says this is fantastic, you should do it, and 15 department heads are all supportive. The trick is how we get through it all, but that's our goal. And then I've been working on collaboration with Troy Hartley, who's the director of the Virginia Sea Grant program at the Virginia Institute for Marine Sciences. We go back and forth on emails. He always has a lot more money than I do, being the Sea Grant director, but just this month we're really talking about an estuarian where freshwater meets saltwater, an estuary conference we're going to try to set up for next year and bring in Sea Grant people with freshwater people. And so Troy and I have met several times. We'll meet again in DC in 2 weeks to discuss this, but we're certainly looking at collaboration. I mean, there's no point in always keeping Sea Grant and freshwater separated. And so to finish up at Virginia Tech, there's more than 90 courses available for our students from 11 different departments. And at this point, somewhere in the range of 100 water faculty across many different departments. And what's amazing to me is I'll get an email, I just got one on Friday from a new urban affairs and planning person I didn't even know they hired, who does all kinds of water stuff in an urban setting, and planning and architecture type stuff. So lots of water faculty, and I think we're set up quite well to meet the challenges, turn them into opportunities as we always try to do, and propel us into the 21st century working on these complex problems. Okay, with that, mahalo, new word I learned in corresponding in the last couple of weeks, and I'm happy to answer any questions or discuss any aspects about here or at Virginia Tech. So thank you. Yeah.
I was wondering if some of the courses that are available are through a law school. Do you have a connection to the law school? For the
No, Virginia Tech doesn't have a law school. There are other law schools in Virginia, but no, and that's an interesting question you bring up, because when we, at Virginia Tech, which is Virginia Polytechnic Institute and State University, has when we develop the undergrad program, and now even as we look at the grad program, we have biophysical science for water, we have it covered. The social side, we do not. We're getting better, we're hiring, people are coming in, and water law is one of the places we have discussed repeatedly, bringing in a water lawyer, possibly, but we teach, there's a water law class, but that's an area that is definitely a place that could expand. Yeah.
How are those PhD students supported in the interdisciplinary program?
In the interdisciplinary program, the PhD students are able to get 1 year of fellowship, research assistantship or fellowship. The other 3 or 4 years need to come from soft money from grant
So the idea is that these are ways to encourage students, either you have a grant on its way or you have an existing grant. This is a way to facilitate bringing in, and I've been on a variety of committees. These are really the best PhD students in the country looking at this stuff. So most of it is on traditional NSF, federal agency, soft money.
Do you have any 4+1 programs in water, so undergrad and then one more year?
Not formal. There's been talk of that, but we do not have that.
You said that you have a strong relationship with the state, meaning the WRC is part of or considered as a state agency or something like that.
Yeah, the Water Center, correct. In 1982, the state created it as a state agency. So we're in the Code of Virginia, we're in the legal code that creates us as an agency, just like a Department of Environmental Quality or Department of Health. So we actually are in the state budget each, every 2 years when they do a state budget in Richmond, our state capital, there's an item in that budget that gives us several $100,000 in state budget. So we are a state agency in that regard.
How was that done?
What's that?
How was it done?
It was done by Bill Walker, who was the Water Center director for probably about 35 years, from the initiation in 1965 up until the mid-1990s, about 30 years. Bill was very effective. He was a lawyer, he was a water lawyer, and it's hard to say somebody who was a water lawyer on the East Coast back in the 1980s or 90s. There weren't very many of them, I don't think. But he was a lawyer. He was very effective at lobbying at the state, and he was a brilliant director who was very successful. And it's to due to his efforts that the state was convinced it was worth it. Yeah. Yeah?
I'm curious about the capstone project
Yes.
at the bottom of that.
Yeah.
What does that look like in the undergrad, and is that planned as a component of the graduate program as well?
Yeah, okay. So I teach that. In fact, what's today?
You're missing
What
your class.
What's today?
Tuesday this
Oh,
week.
no, the class is Thursday afternoons, and I get to miss it this week. That's a class where, for the capstone, the students are, and there are 42 students in there this semester, 8 grad students, and 34 undergrads. Many of them water students, but then there's a smattering of students from all over campus. The only requirement is that you're junior or senior standing and you're ready to give it a shot. There's no other formal requirements. But the main focus there is on finding a watershed anywhere in the world, assessing some issues on it, whether it's water supply or water quality or both, and then assessing the issues, developing a plan that might accommodate or work on the issues. And there's a major focus on the social side. They have to deal with stakeholders, who needs to be at the table, what are the economic, political, social, cultural ramifications. We get watersheds everywhere from Nepal to, a lot of them will do the watershed they grew up on. Many of them in Virginia. And they have to also look at the biophysical mechanisms by which they can improve water. And what we do is we create teams. You know, it's a typical student teams. We create teams of 3 or 4 students. They hate it. No one likes being on a project, on a team effort. But the real world, we're all on teams, and we all have to deal with it. And so we get through it. Every year, I've been teaching for 29 years, and every year I think I have it figured out in terms of how to overcome issues. Nope. each year there's some new issue, and that's just human nature. But the main thing is a group project, and this year we're doing something new. Some years we do current events where the groups get together, different groups, and look at a current event and present it to the class. But this year, starting next Thursday when I get back, we're doing debates. I found that doing student debates really activates and gets very active student learning. And what's really cool is we're doing one on the pipeline. Okay, so as of next Thursday, there's 3 students who have to say pipeline is good for Virginia. You can use all the arguments, and it's going to bring in new money, it's bringing in new jobs, the economic side. And then there's another group of 3 that say it's not good for Virginia. And they debate 3 against 3. And what's cool is you throw students randomly into a side that they don't support personally. But they're going to have to say this is good for Virginia or it's bad. The other one is waters of the U.S. They're going to debate that next week. The Trump administration's, retrieval or rebuttal of back in December, the waters of the U.S. And the third one for next week is the effectiveness of the total maximum daily load program, TMDLs, in the Chesapeake Bay. It's working. No, it's not. And I've done this in other classes, and it really gets students engaged. And part of the grade is the rest of the students vote on who won or lost the debate. So everybody kind of gears in. They're not all doing their normal stuff. Are there students here? Yeah, the normal stuff where you could be looking at your emails or anything else in class. Anyway, long-winded answer, but that for the grad program, we're looking at basically an interdisciplinary issues type class, and we're also looking at an ethics, a professional ethics and issues class that students will have to take to force them to think about some things in different ways. So that's all a work in progress for the grad students, so very challenging.
Any final questions?
Final
for
questions,
Steve
and
before we
there's some
wrap
pizza
up?
back there too.
I know we don't have a schedule, so if you want to hang out for a little while
I'm happy to
afterwards,
chat.
you can come engage Dr. Schoenholtz. Otherwise, let's thank him again for his presentation.
Yeah, and thank you all for coming out.
Yeah, there's been I did ping Janet on there.